Arithmetic and Pure Maths faculty. Today we are discussing about polygons. Polygon. What is the polygon? The polygon is nothing but it's a closed figure with a minimum 3 sides. This is one of the polygon. This polygon is called triangle. This is one of the polygon. This is called quadrilateral. 1, 2, 3, 4, 5. This is a pentagon. And next 1, 2, 3, 4, 5, 6. How many sides we have? 6 sides. This is a hexagon, which is the sides have 7 sides. 3, 4, 5, 6 and 7. This is hepta or septagon, which is the side with the 8 sides, which is polygon with 8 sides, is called octagon, which is the polygon with 9 sides, called nonagon, which is the polygon with 10 sides, that is called decagon. Decagon. After 10, how many sides have the polygon? That is called n-gon. N-gon. If it was a 15 sides, 15 gon. If it was a 20 sides, 20 gon. If it's 30 sides, 30 gon. So this is the polygon. In this polygon, we have a regular polygons. Examination point of view, the question will be framed from regular polygon. What is the regular polygon? The regular polygon is, in a polygon we have a sides and angles. For example, if you take one, 2, 3, 4, 5, 6. So we have 6 angles. We have a 6 angles. Any of the polygon with n-sided polygon. With n-sided polygon, the sum of internal angles. Sum of internal angles are n minus 2 into 180. Sum of internal angles is n minus 2 into 180. Mari, how many sum of internal angles in this polygon? Right, let us see. This is 6-sided polygon. 6-sided polygon is known as hexagon. Its name hexagon. In hexagon or 6-sided polygon, sum of internal angles. Sum of internal angles. So this is angle 1, angle 2, angle 3, angle 4, angle 5, angle 6. Angle 1, angle 2, angle 3, angle 4, angle 5, angle 6 is equal to 6 minus 2 into 180. 6 minus 2 means 4 into 180, that is 720 degrees. So sum of internal angles is 720 degrees. So each of the different angle may be, if the each of the internal angle are same. Each of the internal angle are same. Angle 1 is equal to angle 2 is equal to angle 3 is equal to angle 4 is equal to angle 5 is equal to angle 6. Is a x, 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 x. The total 6 are equal. So it was 6 x degrees is equal to 720. X degrees is equal to 720 by 6. 6 1 is 6, 6 2 is. each of the internal angle is 120 degrees. And that means in a hexagon, the each of the internal angle is 120 degrees. So each of the internal angle is same when in a polygon, each of internal angle are same. Those polygons are called regular polygon. Right? Is it clear? So regular polygon is nothing but the each of the internal angle should be same. Each of the internal angle should be same. Right? How they are? Then the internal angle we will discuss. So what about external angle? For example, each of the side was extended. When it was extended? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Let's see the each of the internal angle when when each of the side was extended, there is an external angle formed with adjacent side. Okay, is it clear? Let's see. This is one of the line segment or line. On a line, at any of the point, there is a 180 degrees. X plus angle 3 180, x plus 3 180, x plus 5 180, x plus 6 180. So x plus 1 180, x plus 2 180. Is it clear? So total 6x plus 6 exterior angles is equal to 180 into 6. 6x already we know that 720 plus 6 exterior angles is equal to 186 0, 6 8 48, 1080. So sum of 6 exterior angles is 1080 minus 720, that is 360 degrees. So in a hexagon, the sum of exterior angles is 360. Not only hexagon, all of the polygons, the sum of exterior angles is always 360. So let's take a point of this. As a polygons, we can form interior angles and exterior angles. The sum of interior angles is based on number of sides. So sum of interior angle is equal to n minus 2 into 180 degrees. So sum of interior angles are depends on number of sides. Next, sum of exterior angles is equal to always 360 degrees. These 2 points have to remember. Sum of interior angles of a n-sided polygon is n minus 2 into 180. The sum of exterior angles is 360. Some of the questions, he mentioned the ratio of sum of interior angles to the sum of exterior angles of polygon. So you observe the ratio for sum of exterior angles and sum of interior angles. The ratio to sum of interior of sum of exterior angles of a polygon. Sum of interior is n minus 2 into 180. Sum of exterior is 360. 182 is n minus 2 is 2. So from this ratio, if he is given the ratio, we can identify the number of sides. If number of sides is given, we can identify the ratio of exterior to interior angles or interior to exterior angles of ratio. The sum of interior to exterior angle ratio is always n minus 2 is to 2. N minus 2 is to 2. Let's see, in this concept, what are the questions are framed. First one, in a hexagon, find the ratio of sum of interior angles to sum of exterior angle, sum of exterior angles. In which one? In hexagon. Hexagon, in that means how many sided polygon? 6-sided polygon, right? In n-sided polygon, sum of interior to sum of exterior ratio, what we discussed? N minus 2 is to 2. N is a n-sided polygon. How many sided polygon? 6-sided polygon. That is 6 minus 2 is to 2. 6 minus 2 is nothing but 4 is to 2. That is 2 is to 1. That is 2 is to 1. So it was 2 is to 1. From this concept, we can frame the another question how it was. Ratio of sum of interior angles to sum of exterior angles of a polygon is 2 is to 1. Then find number of sides. Find sum of interior angles. Okay, in this question, the sum of interiors to the sum of exterior angles of ratio is 2 is to 1. Already we know that sum of interior to sum of exterior is n minus 2 is to 2. Okay, so 2 by 1, a is to b means a by b is equal to n minus 2 by 2. N minus 2 by 2. 2 is come to the right side. 4 is equal to n minus 2. N is equal to 6. So how many sided polygon? 6-sided polygon. So 6-sided polygon means it was a hexagon. So find the sum of interior angles is another question. Okay. What is the ratio? Sum of interior to sum of exterior is 2 is to 1. We already discussed that the any of the polygon of a sum of exterior angle is always 360 degrees. So sum of exterior angles is one part is 360 degrees. Sum of interior angles, two parts is double to itself, that is 720 degrees. So sum of interior to sum of exterior is 720 degrees. Okay, clear? Right. That's very easy. So when he is given ratio to the sum of interior angles to sum of exterior angles, we can easily find the number of sides of a polygon. How can we find? So you simply take a ratio is given 2 is to 1. It was modified to always exterior angle value to equals to 2. To become the equals to 2, it is multiplied with the 2. That is, we get 4 is to 2. The sum of 2 ratio is 6-sided polygon. So when we add it was, the exterior angle ratio should be 2. If it was not 2, you can equal to the 2 with the exterior angle by multiplying the 2. 2 2s are 4, 2 1s are 2. The sum of both ratio is n-sided polygon. Okay, clear? It was 6-sided polygon. It was very easy. Same question. If it was changed as a ratio 7:2, find the number of sides. You observe, what is the ratio of sum of interior angles to sum of exterior angles? The sum of exterior angle is constant as 2. If it was 2, no need to change. So it was a 9-sided polygon. Okay. Find the sum of interior angles. The exterior angles is always 2 parts. That is 360 degrees. That is 7 parts. How much? 7 by 2 into 360. 2 180 is. Okay. 187 0. 1260 degrees. Okay. So, from the ratio, we can find out the number of sides. And also from the ratio, we can find out the sum of interior angles also. Right? This is the polygon of interior to exterior angle. Okay. In a polygon, the sides and angles, in the same way, we have another length that is a diagonal. Which is the longest length in a polygon? It's called a diagonal. The diagonal. Okay, diagonal. Whatever it is, it was a quadrilateral. The diagonal is nothing but which is the line from one vertex to another vertex. One vertex to another vertex. Okay. So, except sides, the remaining all the lengths are called diagonals. How many diagonals can be formed with a n-sided polygon? In n-sided polygon, number of diagonals in n-sided polygon, number of diagonals are n into n minus 3 by 2. That's simple. N into n minus 3 by 2. N vertices are there. From n vertices, we can draw the triangles, we can draw the diagonals for except 3, remaining all the vertices we have a diagonals. So from this vertex, 1, 2, 3, except 3, we can draw the 1. Fine. From this one, we can draw the triangle, we can draw the diagonal 1, 2. From this one, we can draw the diagonal this. We can draw the diagonal. We can draw the diagonal. We can draw the diagonal. Okay. From 5 vertices, from each of the vertices, we can draw the 2 diagonals. Means out of 5, we draw only 2 vertices. So the remaining 3 are not able to draw the diagonals. So that's why the remaining 3 are removed from the n-sided. From the n vertices, we can draw the diagonals of n minus 3. Why by 2? It was repeated. See, from this one, from this one. And repetition is there. So for the reason of not accepting the repetition, we can divisible with 2. We can divide with 2. N into n minus 3 by 2. In the question, in a 7-sided polygon, how many diagonals we can draw? In a 7-sided polygon, how many diagonals we can draw? So 7-sided polygon, that is 7 minus 3 by 2, 7 into 4 by 2, 2 2s are 4. So we can draw 14 diagonals. How many diagonals we can draw? 14 diagonals we can draw. Okay. This is simple. So number of diagonals. Come to the regular polygon. What is a regular polygon? Regular polygon is nothing but in a polygon, each of the interior angle should be equal. That is called regular polygon. Simple. For example, in a 8-sided regular polygon, find the each of interior angle. Okay. In a 8-sided polygon means there is a 8 vertices. In 8 vertices, there is a 8x degrees of each. Each of the x degrees, the sum of the interior angles is 8x. When sum of the interior angles is 8 minus 2 into 180. So x degrees is equal to 6 into 180 by 8. 2 3s are 2 4s are 4 4s are 16. 4 5s are 20. 45 3s are 135 degrees. 135 degrees. So in regular polygon, in n-sided regular polygon, each of interior angle that is n into n minus 2 by n into 180 degrees. So each of interior angle of a n-sided regular polygon, that is n into n minus 2 by n into 180. N into n minus 2 by n into 180. So when interior angles are same, the exterior angles also same. When each of exterior angle is equal to the any of the polygon, the sum of exterior angle is 360. Out of 360, there are n-sided polygon means there are n exterior angles are there. So it is 360 by n. 360 by n. So any of the polygon, at the vertices, the exterior angle plus interior angle is equal to 180. From this key point, we can easily identify the what is the interior angle of a regular polygon. So for this question, how can we find out the without using the formula of n into n minus 2 by n into 180? So 8-sided polygon, the exterior angle is 360 by 8. 4 2s are 490s are 245 degrees. 245. So exterior angle is 45 degrees when interior angle is equal to. Exterior plus interior is equal to 180. Then interior is equal to exterior angles go to the right side of the equals. So that is 180 minus exterior angle of 45. So we can write as 135 degrees as the interior angles. So in examination hall, we are going to find out the interior angle with the point of exterior angle. Okay. So not using the direct formula of interior angle, we can use the answer the question with the exterior angle of idea. Okay, exterior angle is 360 by n. Find out the each of the exterior angle of a n-sided regular polygon. From that, if you subtract the exterior angle from the 180, you get the interior angle of a regular polygon. Okay, simple. Next thing, in a polygons, the properties of quadrilaterals is the very important. Quadrilateral. Simple. The basic properties of quadrilateral. First point, sum of four angles of quadrilateral is 360 degrees. Next, it's have two diagonals. And we already know that we have a four vertices, four sides, and four angles. Okay, so the sum of four angles are quadrilaterals as 360 degrees. It has a two diagonals. The properties are depends on the angles between the sides, how the sides are formed, how the sides are there in the quadrilateral. Is it parallel, or is it bisects, or it's equal? How it was in that way, the each of the properties are changed to the one quadrilateral to another quadrilateral. So types of quadrilaterals